Hi, this is Leetcode question. Get largest element in a stream. In this example, k equal 3, and initially we have these values 4, 5, 8, and 2. The first call to add, we need to add 3, so we add 3 to this array. Now we need to learn to return the kth largest element, so let's sort this array. After sorting it comes 2, 3, 4, 5, 8. Now the third, k equal 3, so we need to return the third largest element. This is the first largest, this is the second, and this is the third. So in this case the answer will be 4. The second call for add is add 5. So if we insert the 5 into this sorted array, it will be in this location 5. So the array is 2, 3, 4, 5, 5, 8. This is the first largest element, this is the second, and this is the third. So we return 5. Now add 10, we add it to the end of this array. And the third largest element is again 5. This is 1, 2, 3, so we return 5. Then have add 9. We need to insert 9 here. The third largest element is 1, 2, 3, the 8, so we return 8. And we have add 4. We can add 4 here, and the answer will remain 8 for the last query. Now we cannot sort the array every time we push an element, because this will take n, log n is the length of the array, and if we have number of queries or addition equal n, so the time complexity will be n multiplied by n log n, and we need to have an efficient array. And to do that we will use priority queue. The priority queue is min priority queue. That means the element in the top is the smallest element in the priority queue. So in the constructor we add all the elements to this queue. So let's insert 4. So now that's 4. And 5. So 5 here. And we have 8. And we have 2. 2 is at the top because it's the smallest. So in the priority queue, the first element always is the smallest element in the array. Now we have k equal 3, so we need only 3 elements to be in the queue, and to do that let's get rid or remove the smallest one. So what we need to do is to pop this element from the queue, and the queue now contains 3 elements, 4, 5, 8. Note that it's not necessarily sorted in this order. What is important is that the first element, or the element in the top, is the smallest element. Now this is what we have in the priority queue. The first add call is add 3, so we add 3 to this priority queue, and the 3 will be in the top. Now here we check if this size is greater than 3. Now we have 1, 2, 3, 4 items. We need to delete the smallest one, which is 3, and we return the smallest one in the top, which is 4. So the first return is 4. Then we call add 5. The queue, it has 4, 5, 8. Now let's add 5 here. Then the size is 4, so we need to remove the smallest one, which is 4. And after we remove this, we have this 5 as the smallest element in the priority queue, so the answer is 5. Now we need to add 10. Let's add 10. Again we need to remove the smallest, is 5, and after removing this smallest, this 5 becomes the root of the tree, because internally the priority queue is implemented as a red black tree, in which the root is the smallest element in the queue. So this 5 become the root, and so we have 5, 8, 10, and we return the smallest element in the priority queue. Then we have add 9, we remove the smallest, we have 8, 10, 9, the smallest is 8, so the answer is 8. Then we add 4, so the queue has 8, 10, 9. Now let's add 4, and at the moment we add 4, it's the smallest, so it goes to the top of the priority queue, and we need to remove the smallest so that the number of elements in the queue is 3. We have 8, 10, 9, and always we return the top, which is the smallest, so the answer for the last add is 8. And notice when we add element to the queue, the time complexity for this is log n, where n is the number of elements in the queue. And also when we remove element, or when we remove the root of the tree, which is the smallest number, also the time complexity is big of log n. Here, this one, pq.top, when we return the smallest element itself without moving, just return, time complexity of this is big of 1 constant time, because it's access the root directly. So time complexity for the whole algorithm is, if we have m queries in addition, so it's n multiplied by log n